This is Algebra Lesson 1-5, adding and subtracting real numbers. Absolute value. The absolute value is the physical distance a number is from 0 on the number line. Absolute value is always non-negative since distance can never be negative. I can't walk a negative 2 miles. I can walk 2 miles in the wrong direction, but I would be walking a positive 2 miles in a negative direction, but I wouldn't be walking a negative 2 miles. Trust me, if you walked that far, your body would know it, and it wouldn't be too happy if somebody told you you didn't walk very far. The symbol for absolute value is two vertical lines. So like I have the absolute value of -3, that would be 3. These would be the symbol for absolute value. Now, absolute value is not the opposite. Don't get confused with that. A lot of people try to tell me that absolute value is the opposite of something when in fact it is not the opposite. Absolute value is always positive. So if a number is positive, the absolute value of that number is still positive. If a number is negative, the absolute value of that negative number becomes a positive number. All right, opposite. The opposite are two numbers that are the same distance from 0 on the number line, but in opposite directions. Okay, so the opposite of -6 is 6. And like the opposite of 3 is -3. And sometimes people refer to an opposite as an additive inverse. Additive inverse is a number and its opposite. But basically an opposite and an additive inverse are one and the same thing. So you can use a number line to help you add and subtract positive and negative numbers. It's very good for visual aid, and it's nice to begin with. However, you need to get away from always using a number line because sometimes numbers get really too big to use a number line, but it is a great way to visualize things and see them for the first time. So if I say 4 plus 7, I will start out at 4, which is right here, and I will move 7 units to the right because I want to add 7 to it. So 1, 2, 3, 4, 5, 6, 7 means I'm going to go to here. So if I started with 4 and added 7, I would end here at 11. So 4 plus 7 is equal to 11. If I say 4 plus a -7, I'm still going to start out at 4, which is here, but now instead of adding a positive 7, I'm going to add a -7, which means I'm going to go the opposite direction. I'm still adding 7, but I'm just going the opposite direction. So if I count over 1, 2, 3, 4, 5, 6, 7, I end up right here. And that means I'm going this way. So 4 plus -7, that means I'm moving 7 units left. So 4 plus -7, if you notice, I end right here, which is at -3. And notice I didn't put the parenthesis in over here. I could have put the parenthesis in here on this 7 here, but I sometimes choose to leave it off. The only time they put the parenthesis in there is not to imply multiplication, but it's to show you how the number is offset from its negative sign. They do that especially with negative subtracting. If you're going to take 4 minus a -7, they almost always put that extra parenthesis in there just so that it sets that negative off so that you can see it. Letter C here says we're going to take -4 plus 7. So we're going to start with a -4 now. So I'm going to start here. And I'm going to add 7, which means I'm going to add positive numbers. So I'm going to move 7 units to the right. Well, to move 4 units to the right gets me at 0. 7 units to the right gives me 3 more units. So I'm going to end right here. So I'm going to go 7 units right. So I'm going to end up at -4 plus 7 is equal to 3. Number lines are great for visually seeing things. However, they don't always work for everything. Like I said, they can be a little cumbersome and they can be a bit annoying to have to deal with. So sometimes it's really, really helpful if we don't have to deal with the annoying number lines all the time. So it's a good idea to learn how to do add and subtract numbers using the rules that I'm going to set up a little bit later. All right, let's take a look at some absolute values. It says, what is the absolute value of each number? What is the absolute value of 3? Well, 3 is 3 units from 0 on the number line, so its absolute value is 3. The absolute value of negative 18, well, negative 18 is 18 units to the left of 0 on the number line, so it is going to be, its absolute value is going to be 18. Letter C here says the opposite of the absolute value of negative 16. Well, the absolute value of negative 16 is 16, and then the opposite of that is negative 16. That's the only time you're going to find an absolute value that's negative is if there's a negative outside of that absolute value to begin with. Letter D, the absolute value of 26, then 26 is 26 units to the right of 0 on the number line, so the absolute value of that is also 26. Now you can use absolute values when you find the sums of real numbers. If you're going to add real numbers, adding real numbers with the same sign, there are basically two rules. What happens if they have the same sign, and what happens if they have opposite signs or different signs. Adding numbers with the same sign. To add two numbers with the same sign, you're going to add their absolute values and give the sum the common sign. Okay. There was a nursery rhyme, row, row, row your boat, that came along that they started doing some positive and negative numbers with. So instead of saying row, row, row your boat, they would say same sign, add and keep. Okay, so the same sign, add and keep. Okay, if you have different signs, okay, to add two numbers with different signs, find the difference of their absolute values. The sum has the same sign as the add-in with the greater absolute value. So in other words, you're going to pretend the numbers don't have absolute values or negative signs to them. Subtract the smaller number from the bigger number, and whichever number was bigger, if it was positive, you make your answer positive, and if it's negative, you make your answer negative. So along with that nursery rhyme, same sign, add and keep, different signs subtract. Okay, keep the sign of the larger number, then you will be exact. That's what the little rhyme came with, and it goes along with the theme or the tune of row, row, row your boat. So same sign, add and keep, different signs subtract. Keep the sign of the larger number, then you'll be exact. Silly little rhyme, but it does help. So knowing those rules, we can continue to add positive and negative numbers. So if I have negative 14 plus 9, well, those are two different numbers. One's positive, one's negative. They have different signs, so we're going to subtract them. So 14 minus 9 is 5, and the number with a larger absolute value is going to be 14, so this number is going to be negative 5. Okay. If I have negative 15 plus negative 4, both of those have the same sign, so same sign, add and keep. So we're going to add 15 and 4 and get 19. Keep the sign. So you add them together, keep the sign. Letter C, negative 3.6 plus 10.8. Different signs, we're going to subtract them. So I'm going to subtract 3.6 from 10.8, and that's going to give me 0.2, 7.2, and it's going to be a negative 7.2, or excuse me, a positive 7.2, because 10.8 is the larger number and it's positive. So this answer is going to be positive. Another way of looking at it is thinking in terms of money. Okay, positive numbers, somebody owes you money. Negative numbers, you owe somebody money. So like for letter D here, if it's negative 11 plus 9, you borrowed $11 from your mom. You paid her back $9. How much money do you still owe her because you borrowed more than you paid her? So if I take 11 and subtract 9, I get 2. And so I still owe mom $2, so I'm still negative $2 in the hole. So if you think in terms of money, it's probably a whole lot easier to remember how to add and subtract positive and negative numbers, because people tend to keep money in perspective and it makes sense to them. So since a number and its opposite are equal, you can use the inverse property of addition to subtract real numbers. The inverse property of addition says that for every real number n, there is an additive inverse negative n, such that n plus negative n equals 0. In other words, 14 plus negative 14 equals 0. Negative 14 plus 14 equals 0. So a number and its opposite equals 0. Keeping that in mind, we're going to get to the rules of subtracting integers. Okay, subtracting real numbers. To subtract a real number, you're basically going to add its opposite. So a minus b is the same thing as saying a plus negative b. Okay, 3 minus 5 is the same as saying 3 plus negative 5, which is negative 2. 3 minus a minus 5 is the same thing as saying 3 plus, the opposite of negative 5 is positive 5, so it's 3 plus 5 is 8. Another way of thinking of it is, I like to refer to it as keep, change, change. I will use this phrase oftentimes in algebra. Keep the first number, change the sign, and then change the sign again. So if you're looking at this first example where it says negative 6 minus a negative 12, notice how we put the negative 12 in parentheses just to show you that it's different from the subtraction sign. It's just to set the subtraction sign and the negative sign apart so you don't think they're one big giant long subtraction sign. So here, if we do the add the opposite, we're going to keep this negative 6, change the subtraction sign to an addition sign, and the opposite of negative 12 is 12, which is the same thing as saying keep, change, change. So I kept the negative 6, I changed the negative sign to a positive sign, and I changed the negative 12 to a positive 12. So I now have negative 6 plus 12, and I can apply all the rules to addition now. Once you've changed it to an addition problem, all the addition rules that we just talked about keep in play. So negative 6 plus 12, I borrowed $6 from mom. I got $12 for mowing the lawn. After I pay back mom, I have $6 left that I can do anything I want with, because negative 6 plus 12, 12 minus 6 is 6. The larger of the two numbers is 12, so it stays positive. 2.1 minus 9.6. We're going to change this to an addition problem. So keep the 2.1, change the subtraction to an addition, change the positive 9.6 to a negative 9.6. Keep, change, change. And sometimes if you keep, change, change, sometimes people will do it that way. I prefer to write it because then I still have my original problem somewhere where I can see it. Now I'm going to take 9.6 and subtract 2.1. So 0.6 minus 0.1 is 0.5, and 9 minus 2 is 7. Negative 9.6 is bigger in the absolute values symbol here, so this would be a negative 7.5. We're thinking in terms of money. I have $2.10. I want to buy something that's $9.60. How short am I? How much money must I earn from somebody else? Or how much money am I short to be able to buy what I want? $7.50. Letter C here, 5 minus 5. So I know you can probably do this in your head and you're like, I did this in first grade. Well, of course, I hope you did. But if we think of it in terms of algebra, we're going to keep the 5, change the subtraction to an addition, change the positive 5 to a negative 5. So we've got 5 plus negative 5, which is 0. And last but not least, letter D here, 4.8 minus negative 8.7. So we're going to change it to an addition problem. So keep the 4.8. Change the subtraction sign to an addition sign, change the negative 8.7 to a positive 8.7. So keep, change, change, keep, change, change. So we end up with 4.8 plus 8.7, and we add those together. 8 and 7 is 15. 8 and 4, 12 plus 1 is 13, so this would be 13.5. All of the addition properties learned in lesson 1-4 apply to both positive and negative numbers, and you can use these properties to reorder and simplify. So remember all those properties of real numbers we learned in the last lesson. We can apply these to positive and negative numbers. So we can order things and group things in different ways if we would like to, as long as it's addition. Okay, so if it says a reef explorer dives 20 feet to photograph brain coral and then rises 7 feet to travel over a ridge before diving 31 feet to survey the base of the reef. Then the diver rises 18 feet to see an underwater cavern. What is the location of the cavern in relation to sea level? Well, first of all, let's rewrite this so that we can figure this out. Diving means they're going down. If they're going down, that's negative. Okay, they rise, that means they're going up. So we're going to say that's positive, plus 7. Okay, and they dive again, that's down 31. Then the diver rises, that's adding 18. All right, so that's all of our numbers. Negative 20 plus 7 minus 31 plus 18. We can reorder this if we want, and I can put all my negative numbers together. So I could put negative 20 minus 31. And then I can put all my positive numbers together, and I could put plus 7 plus 18 if I wanted to. All right, that's one way of doing the problem if I wanted to. All right, or I could just do it straight across the bow if I wanted to. So if I do these, I've got negative 20 minus 31, which keep, change, change. So this is going to be negative 51 plus 18 plus 7 is 25. So I have negative 51 plus 25. Okay, so just think of that. Negative 51 plus 25. Well, negative 50 plus 25 would be negative 25. So this is going to be negative 26. 51 minus 25, and then give them the sign of the larger number. I mean, you could do it this way, or you could do it in the order that it was written. Negative 20 plus 7 minus 31 plus 18. I could do these first two, and I could do these two. Okay, so I could do negative 20 plus 7, which is negative 13, minus 31 plus 18. Okay, I can do that, and I can say, oh, I can put these together and make that negative 44 plus 18. I'm still going to get negative 26 no matter which way I do it. As long as I pay attention to those negative signs, I should have the correct answer. But the order, as long as I'm putting the same number of negative numbers together, positive numbers together, or making sure that I keep the order neat and tidy, it will be fine. All right, so, and I should put plus, and there should be a negative in front of that 31 right there. I should write that a little bit better. Plus negative 31, there we go. All right, so the question I'd like you to answer at the end of your notes today. On a number line, how is subtraction of a negative number related to addition of a positive number? Think about that and answer that question for me.